Hi guys, good to see you. Yeah, it's me, Wayne, turning up again like a bad penny. So I've decided, I promised about 9 months ago to do another auto collimation slash straight edge video, and taking me most of the summer to get to that point. And I thought I'd show you what I've been working on, what I've done up to this point. It's kind of been dragging on because I've added some complications and I've been trying to figure out the best way to go about doing it. So let me show you what I've got, and this is going to be a short video, not the whole thing. I'm going to show you what I've done up to this point. I got some other measuring I want to do on this straight edge, but to make a long story short, back end of September, the end of September, beginning of October, 5-day class, we hosted Richard King at Gearworks in Springfield, Vermont. Don Shattuck, hope I said his last name right. Don, the owner of Gearworks in Springfield, owns a business that he rebuilds fellows, gear hobbers, gear shapers, and makes gears. He was a fellows field engineer, I think, for a long time, so he's got a lot of experience. And he owns owns one of the old fellows buildings in Springfield. So the third floor is basically a scraping shop, and he was gracious enough to allow us to hold the class there. Like I said, the end of September, beginning of October, for 5 days. And it was a machine rebuilding slash scraping class. So first couple 3 days you learn hand scraping and power scraping, and then you move on to projects and either lathe, cross lathe ways, or milling machine ways, or I did a straight edge, this 24-inch straight edge, and a friend of mine, Warren Jones from New Hampshire, he did a bunch of stuff. He did a right angle, and I forget what else he did. He did a couple things. He did a right angle, did a couple straight edges, I think, and he also brought in a Bridgeport table to inspect on 3 points. There was quite a crew there. It's pretty interesting. Highly recommend it if you can manage it to get into one of these classes. Some people might think it's a little pricey, but I think it was well worth it. It was everybody got their money's worth out of this thing. So Richard's a good teacher and very knowledgeable, and again, if you can at all take a class with him, I recommend it. Well, anyways, I'm going to turn this camera around. I'll show you the straight edge, the surface that I scraped on it, at least one side of it, because I'm not done with this side yet, inspecting it. And I'll show you my setup that I've come up with the Autocollimator to make it easier on my back and quicker to do an inspection on this thing. And a couple of little things I ran into while working my way around inspecting the thing. So here we go. So like I was saying, I got a different setup going here. Works pretty good, I think. So over here, obviously, I've got the Autocollimator, and I've got a Canon DSLR I'm using to image through the eyepiece. And I'm imaging the screen here. As you can see, there's my reticles, my crosshairs. And I don't know if I zoom in too close, I think I get a weird effect. But there we go. Yeah, I suspect you're seeing that moire pattern, they call it. That's the scan rates of this laptop screen and the 30 frame per second interacting. Which you can see, I got the reticles and with the crosshair in the horizontal double reticles, and I've got the crosshair in the center of it. So that allows me, so instead of moving, and then I've got the straight edge here. It's up on 1-inch gauge blocks, and it's probably too dark here to see, but you're going to have to take my word for it that in line with the gauge blocks right here, I've got a line marked, which are the airy points technically I think they're bezel points, but I'll talk about that in a later video. But I've got at the area points. Here's the one side of it. I've scraped both sides. Here's the side that I scraped. One side that I scraped. So when I started inspecting this thing, what I found out was rather quickly was, oh gee guys, you know what, I've just spent hours scraping the straight edge straight and parallel, and when you go check it with a reference mirror with an autocollimator, you have little pads here, and these little pads have there are spheres on the bottom. They're spherical, because obviously you don't want flat pads, because you want the thing to be able to follow the surface and move with the contours. Well, all these scrape marks are anywhere from 1/10 to 2/10 to 3/10 deep or so. And so the mirror does this wibbly wobbly action, and I had a lot of issues trying to make sense of what I was seeing. So in Moore's book, Principles of Machine Accuracy, is that what it's called? I forget now. I've got the book and I forget the title. But in it they talk about how, and indeed we did this over at the class when we were indicating our projects with a 10th indicator, if we weren't checking the depth of the scraping marks with the indicator, we wanted to check to see how parallel it was or how flat, we used a gauge block for a little gauging block, Moore calls it. And so there I have one of these little round gauge blocks I've got one there, you can see it under that pad, and I've got one under this pad. So this one here isn't nearly as critical, and then of course I've got one, you can just see it under the edge of that pad. So that averages out, basically you're averaging over the diameter of the gauge block, you're averaging all those divots, little scrape marks out. So obviously the smaller the diameter of the pad, the more accurate it would follow the surface, but really I don't think this is really bad, this size block. I am planning on making a little hardened steel pad that these feet might drop into, because right now, I'll show you what I have to do. Right now, well, let me see if I can swap hands here and not break anything. What I basically have to do is I have to take the mirror off, and then I move to another testing position. Let's say this one here. And I have to make sure the blocks I don't feel any grit or dirt underneath them. Then I have to slide this block assembly over like so, and then I have to pick the reference edge back up, mount it back up, make sure it's not going to fall on me, and as you can see, it's been following pretty good, as long as I'm methodical and thorough and clean all the dirt out, make sure there's no grit anywhere, make sure everything's lined up. This has actually proven to work pretty good. So anyways, this is kind of like where I'm at right now. Now, I've had it for one day. I'm tired because this is the only thing I've done. I've done a lot of other things today too. And I think I'm going to take this video upstairs and start looking at or take this upstairs and look at editing it into a video. But what I want to do ultimately now, the next, is I'm going to move these gauge blocks out to the very ends and see if I can detect any difference from here. I'll take you over to the other computer where I have the points plotted. And in fact, here's my rough worksheet here. You can see some numbers, the numbers that I got. And I don't know if you remember, I'll talk as I'm walking, trying not to break anything here, because it is a little cramped. I'm ashamed to admit in my cellar. I should not be this bad, but it is. Another workstation over here, and I've gauged I've graphed the data points that I generated. I start, basically, I go starts down at I think it was like 28 millionths of an inch or so, the first two. Then it drops down to, I don't know, 50 some odd millionths, 60 some odd millionths, 60 some odd millionths. And these are just the points. Essentially, it's going downhill this whole time. And I got to figure out how to graph that. Actually, I think I know how to graph that. But anyways, I wanted to see what these points look like plotted. And it's not, if you think about it, all these points are negative. Which means very little other than it's a directional tilt bias to the plane, reference plane. But I'm going down the whole time, except even here where this 10 millionth of an inch is still a negative 10 millionths. So this whole thing is going down like this on the surface plate, and it's undulating, and it undulates a bit up here, but cumulative total, I don't know what that's going to be right off the top of my head. Somewhere probably around a tenth or a little over a tenth. I'll do the math here, and maybe I'll do that real quick and then add to this video what it comes out to. But the testing I did over on the big surface plate at Gearworks when I scraped this thing showed that I had this straight within a tenth. It started, I don't know if you go back and watch the video I did 9 months ago, the initial test with the straight edge on its side, it was out of straight a little over 3/10 thousandths of an inch. And when I took it over there, we have it's got to be a 36 by 48 or something steric granite plate, AA grade, we were using as a scraping master. When I put the straight edge initially up onto the straight edge and just hinged it, you could see where the one side had the positive belly in it and would spin right around the middle, and you'd flip it over on the other side and it would hinge out on the ends. So it had that defined 3/10 curve in it that I alluded to back 9 months ago. And now it doesn't do that. Now it hinges hinges right. Usually when hinging is when you take something down on a flat plate like that and you move it. If it's straight, it'll tend to have pivot points around a third of the way in on the part. So you break the thing up into thirds, and those 2 points on either side of the center third is where this thing should hinge, and it hinges right there. And I think this is showing that level of straightness. I'll go off now, and I think I will run a sum of these numbers, and then I'll just append it to the end of the video here. So hang on. Okay, so now it's running. So this is the results of the Autocollimator test on my straight edge. These are the readings I showed earlier. As you can see, I have a substantial error here, 4.5 tenths, which I found excessive due to the testing that I'd done on the straight edge on the surface plate when I was scraping it, both with the bluing and the 10th indicator we used over there. Everything pointed to it being reasonably flat and straight, say like, a tenth or so, but not 4.5 tenths. So, in looking at the data, I decided that it had this downward tilt. All these numbers are negative. Like before with the Autocollimator, you saw that nice curve down. It had a belly in it. It went down 3/10, and then it curved back up, and the readings went from negative to positive. And there was a mix of positive and negative numbers, and here they're all negative. So I decided to do some research. So I went online, and I'm going to, let's open this one here. So this is in researching tilt on the internet, I came across this paper, and I'm planning on doing a video, another video after this one, hopefully a lot sooner than this one came, not 9 months later, but a matter of a couple weeks, of a reversal technique. But basically the paper says that due to misalignment between the artifact and the axis of the guideway, you can get a tilt, this error. So you do what's called an endpoint fit or a least square fit. And I decided, because I had already had the data in a spreadsheet and I could insert a trend line, I could do a linear regression or a linear least squares fit to this data. And I did, which I did, and I got this equation here. And then what you do is you basically take each point, and in the same x location for each actual reading, you calculate what the theoretical perfect line would be to fit that data. Then once you have those numbers, you then do a subtraction. You subtract this. This is called the residual. These are residuals. You subtract the residual from the actual reading, and you come up with the true straightness values, which are these here. And as you can see here, there's no longer a tilt. You do have some that go up, and you have some that go down, up a lot, down, and then up. And indeed, when I say a lot, these are all millionths of an inch. So it's not really a lot. But if you add these up, and I don't think this number is correct here, because just in my head, if I go, this is 47 millionths, just round it to 50, say 50 millionths to negative, 50 millionths to negative 20 millionths, that's 70 millionths of an inch. So this isn't 9, it should be more like a 7.0 to the negative 6. But I did a sum, and I didn't really spend a lot of time trying to debug that. I probably should, but just looking at this, and 70 millionths, that's 3/4 of a tenth. So that's reasonably close to what I got just on the surface plate. So that's basically where I'm at. Now, one principle I believe in firmly in metrology is that if you have a measurement, it never hurts to do more measurements, and with different instruments, to try to verify, confirm, see if you have some agreement between the different measurements and methods to give you a little more confidence in your measurement. So that's straight edge. I have the bluing test on a hopefully a good Starrett surface plate. I have the 10th test that I did over there, again on that same surface plate, which seemed to indicate about a 10th or so error. Then I come over here with my autocollimator, and I get these initial numbers. So now I'm breaking into new ground. I'm not sure where I'm at. So I've decided, based on this article, that's not what I wanted. Let me get up. Let me see here. This one. Decided I would pursue these reversal techniques, and I'm going to do, my next video is going to be on those. The 3 main ones that I've learned about, and I think you'll find it quite interesting. Now, like I said, hopefully that this video will come a lot sooner than this one did. This one was 9 months after the fact. This next one, I hope to get it done in the next week or two, because I'd really like to move on to another project and use the straight edge for what it was intended for, which was scraping in the ways on my shaper that I'm rebuilding. So with that, I'll wrap this video up, and I will see you. Oh, and I will put some links to at least this paper here. What's it called here? Reversal technique applied to the measurement of straightness errors. I'll put a link to this in there. And then the following video about the reversal techniques, I think I'll
put a couple more links in. So with that, thanks for watching. Thanks for watching this stuff on my channel. I really appreciate it. Any comments, I love hearing from you. Again, just, constructive criticisms if you have criticisms. I can take criticism. I like to learn. I like to improve. Just don't say anything too off color, which nobody has up to this point, and really, I don't see why anybody would. So with that, thanks again, and we'll be seeing you. Bye.